I've seen him giving some talks over here as well.
I think today morning he had some workshop or something on Gluster.
You have the scars that you can give to people who are asking good questions and so on. Yeah, I should have seen the lace.
This I got it from Amy.
Hello everyone, we are starting the next talk. Please keep your mobiles on silent, check the messages, keep them silent then. If you are going to enter this menu, please be careful with the doors, they're quite noisy, so just be quiet with them. Today at 4:30 in auditorium D105 there will be competition with prizes, so we encourage people to come over and to be there. There are some Raspberry Pis, some other things that you can win as a prizes. Maybe there will be even a few DEFCON hoodies. So come over and take part in the competition. For those who is here, we have a few scarves that presenter can give as gift for the good questions. And that is it about the organizational part. So now please welcome Ramesh, who is our Gluster engineer.
Hi guys, I'm Ramesh Nachimuthu, working in Red Hat Bangalore for OVirt team. Mostly I work with OVirt and Gluster integration. Today I'm going to talk about Ovirt and Gluster Hyperconvergence. So how many of you know OVirt? That's good. How many of you use OVirt? Great. And with Gluster? OVirt with Gluster? Cool. This might be interesting for you now. This is going to be my agenda for next 40 minutes. First I will introduce you to OVirt. Maybe most of you seems know. I will just roughly talk about the architecture and storage. Then I will talk to you about hosted engine. Then I will introduce you to Gluster and basic components in the cluster. Then we will see how to set up a hyperconverged infrastructure using OVirt and Gluster. How it looks and how to set up and how do you manage the setup. Then I will talk a little bit about the recent enhancements we did for hyperconvergence case in OVirt as well as Gluster. Let's get started. So basically OVirt is a virtualization management platform which helps you to manage your virtual machines, also for storage and networks for the virtual machines. Yes, if you see from the diagram, on top we have the OVirt engine that runs in a separate hardware and inside a JBoss application server. That the OVirt engine is written in JBoss, written in J2E and runs in a JBoss application server. That takes care of managing your hypervisors and storage. OVirt engine uses PostgreSQL as a DB, and that exposes main two interfaces for the user to communicate. One is the web admin portal where you can define your cluster, you can add your hypervisors, you can add your storage nodes, and you can create your virtual machines there. Also, it exposes nice REST APIs which can be used to integrate OVirt with other management platforms like ManageIQ or CloudForms, etc. Below OVirt you see the clusters. It's like a cluster of hosts. Those are all virtualization enabled. Mostly we use KVM virtualization. That takes care of running the virtual machines in the host. OVirt uses something called VDSM. It's an agent or daemon running in all the hypervisor, and it's written using Python. That takes care of all the hard pulling for OVirt. OVirt communicate to host through VDSM. It asks VDSM to like create a virtual machine or stop the virtual machine or start a VM, attach disk. All those hard steps are done by the VDSM. Just the engine manages the hosts. And underneath you see storage. So traditionally OVirt supports different storages like NFS or FCP or iSCSI and Gluster FS as well. That can be managed by Gluster or managed by OVirt, or it can be independent of OVirt like iSCSI or FCP or NFS. Next we will see specific about storage architecture. So storage is the main component in OVirt because the VDSM completely relies on the storage to store the virtual machine images and as well as the config files and other things. Also it relies on the storage for synchronization between the VMs. Like the same VM should not be running on multiple hypervisors. Also the locking and synchronization is handled by SANLock, and that's done through storage domain, which is this actual storage here. And OVirt supports these storages like NFS, FCP, iSCSI. There is one difference between other storages and Gluster FS because NFS and other FCP storages are single point access where you have to communicate to a host to get your storage. But Gluster FS is different because it's a clustered file system and it has multiple hosts. So if one host fails, VDSM or OVirt can talk to other hosts to get the VM images or other data. That's why Gluster FS is more useful. Next, the hosted engine. If you see in the previous slide, OVirt engine runs in a separate hardware, and that's again what if that machine fails? That's a failure point. Also, you have to dedicate one hardware for the VM, for the OVirt engine. Instead, you can use something called hosted engine, where the OVirt engine itself will run in a VM, and that VM will run in any of those hypervisor hosts. You can get rid of one host, one physical host. Also, you get cache. If one host fails, the OVirt engine can run on another host. You get cache for OVirt engine as well. So, in this hosted engine setup, there is something called hosted engine cache agent, which will be running on all the hypervisors, so that if one host fails, the other host will automatically start the hosted engine on it, and that can manage all other hosts. So in the end, the OVirt engine will be always running, and you can always manage your hosts. But it's kind of chicken egg problem because since you have a VM which manages itself and the other hosts which are running the VM. So what you need is you have to do bootstrap deployment to bring up that VM, then add the other hosts. Maybe I will talk about this later with more information or exact steps, how do you do it. Okay. That is about hosted engine. Next is Gluster FS. As you all know, Gluster FS is an open source distributed file system. It runs on any commodity hardware and it can scale up to petabytes easily. As you see in the diagram, it can be accessed through multiple protocols like Gluster FS or NFS, any SIFs or lately Gluster API. What it does is basically aggregates different storage exports, like different storage exports from different hosts and give it in a single namespace, which is more reliable and replicated or distributed. There are multiple things. Maybe next slide I will talk about the basic things. So brick is a basic component in OVirt, in Gluster. It's the actual place where your data is getting stored. It's actually a mount point. You see from this diagram, you have a block device in the system, and you format it, you get a file system on it, and you mount it on your system, and that mount point becomes your brick. The brick is a place where your actual data is getting stored, and the limitation on the brick is completely on the system. There is no limitation from the Gluster side. Whatever the brick can hold, whatever much the amount of data the brick can hold is completely and up to the file system and the disk. Next is Gluster FS volume. So this volume is the actual collection of bricks. As you can see we have 3 bricks from different hosts. You can combine all these hosts and export them as a single volume. And Gluster FS supports multiple types of volumes called distribute or stripe or replicate. If you take distribute, where your data is distributed across different bricks. For example, if you have 3 files called file 1, file 2, file 3, and each file may go into different bricks, so that you can access them easily from different hosts. Another is replicate. The replicate is more reliable, especially in case of virtualization and other use cases where you need a reliable data and you don't want to lose your data at any cost. There you can use a replicate volume where your data is replicated across bricks. The water file, you write it in a volume, is replicated across all the bricks in the volume. At least in case of replicate 3, it replicates in 3 bricks. Also you can combine them. You can make distribute replicate or distribute stripe or other cases. Like you can combine all of them. And another important aspect here is the quorum. Gluster FS supports something called quorum. So if you enable quorum, you can avoid split pane. The split pane condition is like, you have 3 bricks, assume 1 brick goes down or something happens, finally end up in 3 bricks having different data. Now you don't know what is the final data or actual data. Those cases can be avoided easily by quorum. If you enable quorum, when majority of the bricks are not there, it will automatically make the file system read only and you can't write anything, so that you can safely recover from your failure. Next, this is about how you access the Gluster FS volume through fuse. At least in virtualization case, you have a QEMU running your virtual machines. If you want to access an image from Gluster FS volume, it goes to kernel. From kernel, it asks the Gluster FS fuse client that requests the cluster brick which is running on the remote Gluster FS server through net, and that again goes to calls the underlying XFS file system. If you see from here, there are a lot of kernel switches happening from user space to kernel space. Ideally 5 switches here. This is not performing well. So what we have is, we have something called GFAP API support. This helps you to communicate directly to the cluster brick and get your volume data. So with this QEMU kernel supports this libgfap API. With this, the QEMU can directly talk to the Gluster FS brick and get the image or volume data, Gluster FS data. There is one bug or one RFE missing in this. Currently, QEMU supports only one host. Though Gluster FS is a clustered file system, currently QEMU talks to only one host. If that host fails, then your VMs will get passed. So we are working on this bug so that if that host fails, even QEMU should be able to talk to other hosts in the cluster to get its volume back. We are working on this patch. Okay. Next is hyperconverged. Hyperconverged OVirt setup. If you see the diagram, maybe let's compare this with the first one. Here, how many hosts you had? One is for engine, another 3 for your hypervisor, then separate storage. At least you need 5-6 hosts here. But in case of hyperconverged, you need just 3 hosts. And the same host will be used for both storage as well as virtualization. This is very useful in case of small scale deployments where you have very limited set of hardware and still you want to try out virtualization techniques. Here we run both Gluster FS and KVM on same physical nodes, and for OVirt engine we use something called the same thing what we explained, the hosted engine. So OVirt engine becomes HA enabled automatically and runs inside a VM that can manage the other VMs, other hypervisors. It can also manage the Gluster FS volume. And these boxes can be standardized so that you can scale out or scale up easily. You can add more storage later to the same host, or you can bring in multiple additional host to scale out your setup. Yeah, this is overall hyperconverged OVirt cluster setup. Next we will see, we had to do some enhancements to bring to this. The first thing was Lit GFAP support. It was not there, now it's there. Since it's there, and replicate 3 volume. So previously, especially with OVirt 3.5, when people tried hosted engine with the cluster, they started using replica 2 volumes and they get into split brain situations. And split brain situations are very costly in OVirt, because when you go to split brain situation, then your VMs are lost or at least passed. You have to reboot them, or most of the cases you have to reboot, they won't resume automatically. And sometimes if you have corrupted data, there are cases where same VM running in different hosts, there are multiple problems. As a result, they stop supporting replica 2 volumes and start supporting Gluster FS for hosted engine. In 3.6 it was enabled with replica 3 volume, so you mandatorily has to have replica 3 volume to use Gluster FS in hosted engine. Now that support is there. Another thing is called OVirt engine appliance. Deploying a hosted engine setup is, traditionally it was very tough, because you have to solve the chicken and egg problem. You have to bootstrap your virtual machine, which is going to run the hosted engine VM, and add the hypervisor hosts. And OVirt had something called hosted engine deployment script. That script is a very interactive script, but it asks a lot of questions. It's all related questions. So if you make any mistakes in between, then you have to start from beginning and you have to clean up the setup. Even we face a lot of issues. But with this appliance model, what they come up with is, you have a pre-packaged VM appliance, which has OVirt already installed. You can just use them. In this model, you could avoid multiple errors in your deployment. Also, that VM can be customized using Cloud Init. Basically, we have to configure few things like what should be the FQDN name for the VM, what should be the username, password, all those things you can easily configure. And one more enhancement is the shared configuration. Previously, though there are three hosts, and VM can run, hosted engine VM can run on any host, but the configuration about the hosted engine VM was stored separately in all these 3 hosts. So if at all if you want to change make any changes, you have to edit same config file in all the hosts to make a change to the hosted engine VM. Now that is being said, that will be stored in the same storage, the Gluster FS storage or NFS storage, whatever is hosted engine. In that way, the configuration will be shared across all the hosts. And we have some mechanism to upgrade from OVirt 3.5 where the configurations are separately stored in all the hosts to move to the shared configuration. And we have a management GUI. So till now, if you want to change something in the OVirt engine VM, like I want to give more memory for the hosted engine VM, or I want to change the processor, number of processor allocated, then you have to edit the config file. But now we can do this through UI. But I came to know that these features were in the last minute it was removed from 3.6, but it will be there in next 4.2 release. Okay, what are the main ingredients for hyperconvergence? You just need 3 physical hosts with virtualization enabled. Then you need at least some 20 GB of memory, 20 GB of storage space in your system, because we are going to run cluster storage there and you are going to run your VMs there. That's very, very minimum. If at all you want to try from a virtual machines, this hyperconverged, you should need these minimum requirements. But in at least in a hardware, if you go to hardware, I hope you will have more capacity by default. The next important thing is you have to configure your DHCP. Basically, you have to reserve a MAC address for your hosted engine VM, and that MAC address would be resolved to a fixed IP, and you should add a configuration in DNS to give a predefined DNS name for that IP, because you are going to communicate with the VM, the hosted engine VM, using the same FQDN always. So that we have to make these configurations. Next, you have to just install the package. And the last point is very interesting, because you need physical console access or network access, that's a standard, but why do you need screen package? It's because, since I told you, the bootstrapping the hosted engine VM is a little complex, and it involves multiple steps like configuring your firewall and configuring your network. You may end up losing your connectivity to the physical server. As a result, if you lose, you have to get back to the same session. That can be done through screen or the physical console. Next. So how do you set up? The first step to set up the hyperconverged setup is setting up your cluster volume. As I told you, we need to replicate 3 volumes. So we have 3 hypervisors. Make a trusted storage pool out of those 3 hosts. Then create a 3-way replication volume, 3-way replica volume at least 1 volume for now. Maybe later we can create another volume. The 1 volume will be used for hosted engine VM, which will contain the disk image for the hosted engine VM. Another volume will be used for regular VMs, which we are going to create. And as I already told you, we have to enable cluster quorum. Otherwise, you may get into split brain situations. Another important feature is sorting. This was recently introduced in cluster. So without this feature, we were facing many problems with the self-heal. When self-heal happens, it eats up the whole CPU time, and your VMs are not getting any CPU, and VMs are getting paused. As a result, either we have to restart the VMs we have to restart the VM. And especially in case of hyperconverged case, even your hosted engine VM will get paused. So it's kind of difficult situation to recover from that condition. But if you enable sorting, your big files, your disk image files, which are anyway going to be big, will be striped into not striped, it's little different from normal striping, will be chunked into different chunks of 512. It's a configurable size. By default, we use 512 MB sort. It will be chunked into 512 MB sorts and will be stored in different bricks. So that self-heal, and it greatly improves the self-heal performance and as well as GROP performance. We tried with GROP as well, and it actually solves the CPU problem. Now with the self-heal, we are not seeing more CPU usage. We had to do a few more tuning, like setting the network peak timeout and self-heal algorithm, and the OVirt group setting the owner ID and user ID to 3.36. Sorry, that should be GID. Okay, next thing is the hosted engine setup. As I told you, we need these 3 packages. One is the OVirt engine appliance, which brings in the OVA image or hosted engine image. Next is hosted engine setup, that brings in the hosted engine setup script, which helps you to bootstrap the VM, hosted engine VM. Next, VDSM cluster, which brings in all the VDSM packages. Then this is our friend, the hosted engine deploy. If you run this script, it's a very interactive script. It asks multiple questions, and these are the few important questions which will be asked. One is the storage type. You have to choose storage type, and you have to enter the Gluster FS volume name with the host. If you do that, next it will ask you how you want to bootstrap your VM. There are 3 options. Either you can use OVA image, or you can use a CD-ROM, or you can use Pixie boot. But as I told you, using OVA image is the easiest and better way. So you choose OVA image. Next thing, you can do some customization to the VM through Cloud Init, and it supports, the script supports on-demand creation of Cloud Init configuration, where you can specify the FQDN name and the root user password, etc. Also, you have to give the MAC address for the VM's NIC, which we have reserved in your configured in your DHCP server. If you want more details or exact commands, please read my blog. I have written this blog to help you with the deployment that covers all the details, exact sequence of commands, what you have to run, what you have to answer. So once you do this, what you get is, you have hosted engine VM running. You can log into the OVirt engine. You can see a cluster with one host where you run the script. So now next step is enabling cluster service. So by default, hosted engine doesn't enable cluster service for the cluster where it's being deployed. So we have to enable cluster service for the cluster. Next, we have to add the remaining 2 hosts to the setup and create another storage domain where you will create your VMs. Any questions? Yannick? Do you have?
I had a question earlier on the configuration. So the network sync time on its own. What do you need to configure that? And do you need to do, or can you do it via the cloud units, or will you do it post installation?
You mean this ping timeout?
Yes.
These are all volume configuration.
So
Cluster volume options.
when you create the volume,
After creating volume, you can set these options actually. Basically, these are all volume options, enabling cluster quorum and enabling sorting. It's all cluster volume options. Yeah. So how do you enable cluster? Cluster was integrated with OVirt, I think, since 3.1 for a long time. Currently, you can manage your whole cluster deployment using OVirt. In this hyperconverged case, we have a cluster where you want to run both OVirt and cluster. So by default, I think it should be fixed in OVirt. By default, it doesn't enable cluster service. So we have to go and edit the cluster to enable cluster service. If you enable cluster service, then it automatically takes care of bootstrapping your cluster host, like managing your firewall, managing your cluster ID service. It also supports volume management. You can create your volumes, you can start, stop, or you can add bricks, rebalance. It supports almost all the cluster operations. And you can use the same REST API which is exposed by OVirt to do all your volume operations. Though we enable cluster and web service for the same cluster, there is one problem with OVirt, because the OVirt engine doesn't consider that it's a cluster service is running in this host when it does fencing or other power saving related operations. What happens is, if we enable power management for a host, and if that host is not reachable for some reason, it will reboot the host. It may not be required in case of cluster case, but still it will reboot because it's not considering the fact that the host is running Gluster FS service. This has to be fixed. Next thing is adding additional host. Since we are done with the first host and we are bootstrapped the hosted engine VM, only thing remaining is adding the remaining 2 hosts to the cluster. Just go and add the cluster. In the add cluster, you will see a checkbox saying, do you want to make this as a hosted engine agent? Do you want to configure hosted engine agent? If you say yes, then it will configure the hosted engine agent on this host as well. But this UI was removed for some reasons in the last minute because of some bugs. So again, the host engine deploy is your friend, which can be used to add additional host. How do you go to the second host, run the same script? This time it won't ask you so much questions, only you have to give the same volume. If you do that, then it automatically takes care of most of the things. Now your second host are there. Similarly, you can add the third host. Now you have 3 hosts in the cluster which are running both cluster and web services. Next is creating storage from cluster. See, I already told you OVirt supports cluster deployment and cluster management. You can create your volumes in OVirt itself, either through WebEngine portal or through REST API. It supports other cluster features like volume profiling, capacity monitoring, geo-replication, volume snapshot, almost everything whatever is there in the cluster. Next thing is adding the storage domain using the Gluster FS volume. So now that we have created a volume which will be used for the regular VMs, we have to create a storage domain using this Gluster FS volume. Here the important point is this one. You have to give the volume path and you have to give the mount options with the backup Wi-Fi server. This will be used to communicate. This will be used to configure the OVirt that, so that when the main host this fails, host 1 fails, it could talk to host 2 or host 3. So this is really required. This is called. So we have developed this dashboard as a UI plugin OVirt. Mostly from, actually we had a dashboard for cluster which takes care of all cluster related entities. Now we have included virtual machine box also there, and this gives you a complete picture of what's happening in your deployment, like how you are doing with the capacity, like how much storage you have in total, how much is used or how much is free, and how you are doing with the CPU and memory utilization, that's average out of all the hosts, and how is the network traffic, and how many hosts are up and how many is in maintenance, and how are you doing with the volume, cluster volumes. We have some different states in the cluster volumes, like volume can be up or volume can be down, that's normal. We have something called degraded. What's degraded is in a replica 2-3 volume, if one brick goes down, still your data is available, but it's kind of degraded. You are not able to access another node. You have only 2 nodes serving the data. That's degraded. We have something called partial, where in a distributed volume, if you lose one node or one brick, your data is partially available, not fully available. That's called partial. You should see those statuses when that happens. Also virtual machines you can see here. If for some reason if your network is broken, you should see some NICs are down or something similar there. This is quite useful. So next, how do you manage your hosted engine? I think we talked about it, a little bit about it. You can change your hosted engine VM configurations like memory and CPU allocation and network configurations through UI, but currently it's not supported. I think it should be in 4.0. Same, it uses the shared storage. When you change something, when the hosted engine VM restarted, it automatically picks up the new configuration and uses it. Next thing is hosted engine management. So in hosted engine, you can configure few things like state transition, SMTP. These things are very important because your OVirt engine is a VM. What happens, for some reason the VM dies, and you may not know that VM died. VM is not running. The hosted engine VM itself is not running, which means you are not managing the whole setup. But in hosted engine, you can configure your mail address. So whenever the VM state changes, either it goes to down from up or up to down or any state changes, you will get a mail notification saying, okay, it's going down, it's up. In that way you are being alerted that something happened, something wrong happens. Also you can configure other things like timeout and the host scoring. The host score is used to define where the hosted engine VM should run. For example, you have different hosts. Among 3 hosts, one host is highly powerful, other 2 hosts are not, they have less CPU or less memory. Then the higher power host will get the highest score and it will run the hosted engine VM. Also we did few enhancements recently. One is cluster FS starting, we talked about it. Another is arbiter volume. Actually, to try out this hyperconverged setup, we don't need 3 volume. We don't need 3 hosts. It could be done with the 2 hosts itself. but for replica 3 volume we need 3 hosts. That can be easily solved by the arbiter volume, where the third brick will not be in case of replica 3, the third brick will be used only for metadata purpose. When you store a file in a replica 3 volume, normally it gets stored in all the 3 bricks. But in arbiter volume, only in third brick only metadata is stored, not the actual data. So that can be very less in capacity. The machine itself need not to have the same capacity as other machines. Another is replace brick. This is important because if you want to replace one node in the host engine setup, currently it's difficult. You have to do some manual steps in the cluster to replace the host. Now what we are trying is that should be doable from the UI itself. You can automatically bring in a new host with a replacement for a old failing host. It will be done through UI, without CLI, any usage of CLI, and the backup all file support in Libert and QEMU, which we talked about. The next session will be focusing more about these talks. That's all I have today. I hope you understood something. Any questions?
What would be the performance impact of running that cluster underneath the KVM thing? So I can imagine if it's heavily used for a database or something like that, doesn't it too much influence the KVM stuff?
I think Gluster FS by default doesn't use much CPU, I feel. That's why I think we are running some tests. We didn't see any major performance issues with those things. The main problem was with the self-heal. When self-heal runs, we used to see more performance issues. But with the sharding, that is also getting reduced. We don't see any major performance bottleneck, we didn't see. But still, we are in evaluation state. We are running some performance tests. Now even with arbiter volumes.
Yeah, and another question. I mean, if the host gets fenced because the manager doesn't reach 3GSM, do we use the knowledge from Gluster about the other nodes to detect if it should get fenced, or just rely on...
No, currently it's not there. That's why we recommend not configuring power management in case of hyperconverged. Any other questions? Thank you.
And how do you introduce it?
Yes, Mr. Mark.
So you have, if you want to use the,
Okay. So
if you want to
That-
use slides forward and back, you need to connect to
how can I do it? How can I do it for down?
connect the dongle.
No. I have here and I have it down this way on the side.
I'm not sure about that. So you can try to connect the dongle, try. So it works this way, but I'm not sure about the down.
How it works?
Then you can connect you can give those away for the questions.
Okay.
And there is some water if you need some.